Good afternoon, everyone. So, in the previous classes, we have started the gaseous fuels. We have discussed there how gaseous fuels are different from our solid fuels and liquid fuels. We also discussed the important properties of the gaseous fuels, their advantages, and how these gaseous fuels are lagging, or what are the main disadvantages faced in case of the applications of the gaseous fuel. And also we have discussed explicitly about the natural gases. So in today's class we will start the synthetic gases. Now what are the synthetic gases? Synthetic gases means the gases which are actually chemically manufactured by using the some processes. So in the today's world there has been a increased interest in the power generation because of the gasification properties of the waste and biomass. So here what happens, we are synthetically producing the gaseous fuels by utilizing the waste materials or the biomass. So some of the common synthetic gases are the producer gas, water gas, and oil gas, carbureted water gas, coke oven gas. These are the some important synthetic gases which will be discussed in the today's classes. Now, how we produce the producer gases? So, in case of the producer gases, what happens? We provide the insufficient air with a little bit of steam to the coke, and that coke is usually maintained at a very high temperature. So as a result, what happens, the carbon monoxide and hydrogens are produced, and some other non-combustible products are also there, like the CO2, nitrogen is also present. So combination of all these gases is known as the producer gas. So in today's class, we will mainly discuss about the details of this producer gas. So in this slide, there are the other type of synthetic gases like the oil gas, carbureted water gas, and the coal and coke oven gas. So oil gas is what? Oil gas is mainly which we derive from the thermal cracking of the crude oil. That means from the petroleum reserves, that means the crude oil, if we break or if we do the thermal cracking, then whatever gaseous hydrocarbons we are deriving, these are known as the, mainly their composition is known as the oil gas. And in case of the carbureted water gas, what happens? If we mix the water gas with the oil gas, then whatever composition and whatever gaseous fuel we derive, that is called as the carbureted water gas. And another important type of the synthetic fuel is what? Coal and coke oven gas, that are mainly liberated during the high temperature carbonization of coal. So if we arrange these synthetic fuels in terms of their calorific value or the heating value, what we have seen that the lowest calorific value is being obtained in case of the producer gas, followed by the water gas, then the higher calorific value is being obtained in case of the biogas, and in case of LPG, which is mainly used in for the domestic cooking purposes, it has been found that the calorific value of the liquefied petroleum gas is very high, around 27,800 kilocalorie per meter cube. So in case of the producer gas, the producer gas is basically a mixture of the some combustible and the non-combustible gas. Primarily four components are present: carbon monoxide, hydrogen, nitrogen, and the carbon dioxide. It has been seen that the around 30% carbon monoxide is there, 15% hydrogen is there, and a huge fraction or huge percentage, that is the 56% of nitrogen gas is present in case of the producer gas, and around 3% of carbon dioxide are present in case of the producer gas. So if we see here that the a very high amount of nitrogen is present, and as we already know that nitrogen does not contribute in the calorific value. So as a result, what happens, a huge fraction of the gases in the producer gas is the nitrogen. So it does not contribute in the higher heating value. As a result, the calorific value of the producer gas is comparatively lower as compared to the other gas. So another gas what we have discussed is the water gas. If we see the composition of the producer gas and the water gas, what we will see that in the producer gas also four components are there: carbon monoxide, hydrogen, nitrogen, carbon dioxide. Similarly, in water gas also these four gases are mainly present. But now what is the difference then between the producer gas and the water gas? The main difference is in terms of their composition. That means the percentage of presence of these four gases. It has been seen that in case of the water gas, the presence of this nitrogen has become comparatively lower. So as the nitrogen percentage is lower, so what happens, the calorific value of water gas is comparatively higher as compared to producer gas. So what happens in case of producer gas and water gas, the component gas is being same: carbon dioxide, hydrogen, nitrogen and carbon dioxide, but the difference is in their percentage contribution. In case of producer gas, the highest contributor is the nitrogen, and nitrogen does not contribute in the heating value. Whereas in the water gas, it has been seen that around 3% nitrogen is being present, which is much lower than the 56%. So that's why the calorific value of water gas is much better than the producer gas. So some important properties of producer gas is that it generally burns with a blue flame, and it is considered the poisonous in nature because of what? Because of the presence of carbon monoxide. And as discussed earlier also, its calorific value is comparatively lower, around 1300 kilocalorie per meter cube. And almost if we does not consider the blast furnace gas, so producer gas is the lowest in terms of calorific value of all the synthetic or the natural gaseous fuels. But in spite of having the very low calorific value, this gas finds its wide application because of its very least cost. So that's why it finds its wide applicability in various furnaces and in various industrial processes. So next we will discuss about the synthesis of the producer gas. So here the reactor in which the producer gas will be produced, this is known as the gas producer. And for producing producer gas or synthesizing the producer gas, what we have to maintain? We have to maintain the temperature at around 1000 to 1100 degrees C. So the mainly the our raw material is here coke, and that coke will be gasified. So for gasification process we have to provide what? Air. So we will here provide the enough air to maintain that temperature of 1000 to 1100 degrees centigrade, but that amount of air will not be sufficient for the complete combustion reaction. That we will discuss in the very elaborate way in the coming slides. So in the reactor, what we can see that in the reactor mainly the diameter is around the 3 meter and the depth of the reactor is around 4 meter, and the sides of these reactors are generally lined with what? A refractory bricks. Refractory bricks are mainly acting here as the insulating medium to stop the heat exchange with the surrounding material. So the here what happens, the main raw material is our coke, which is heated and are maintained at around the temperature 1000 to 1100 degrees centigrade. There we will supply what? Air with a little bit of steam for carrying out the gasification process. So here you can see this is the main reactor. This is the main reactor, that is the gas producer reactor. Here we can divide the total reactor into gas production reactions into mainly 4 zones. And what are those zones? Those zones are the ash zone, combustion zone, reduction zone, and the distillation zone. So you can see from in the bottom zone, this is known as the ash zone. Ash zone means what? Where the ash will be collected after the reaction. This zone is called as the ash zone, and this is the bottom zone of the reactor. The next zone is what here it has been shown that this zone is the combustion zone. In the combustion zone, what is the action of the combustion zone? In the combustion zone, main combustion reaction will be taking place. Followed by the combustion zone, the next zone will be the reduction zone, where the mainly reduction reaction will be taking place. And followed by this, the last section, that is the upper section, is known as the distillation zone, where mainly the separation takes place. And here another point is that the combustion zone is also known as the oxidation zone. So what happens, we have discussed that in case of the ash zone is the lowest zone, and here mainly it is named as the ash zone because it collects the residue ash. That's why that zone is known as the ash zone. But it has a very important role also. This ash protects the grate of the producer from the intense heat of combustion during the reaction. And as a result, what happens? The temperature of the supplied air and steam is increased as they produce through this chamber. So this ash zone is what? This is the lowest bottom zone of the reactor, where the producer gas production will take place. So in the next zone is what? Next zone is known as the combustion zone. So this is the most important zone of the reactor. So this zone is present just top to the ash zone. This zone is also known as the oxidation zone because here the oxidation reaction takes place. So what are the main important reactions that takes place? So whatever coke is there, this coke is present in around the temperature 1000 to 1100 degrees centigrade that we have already discussed. So the first reaction is carbon plus oxygen, and it will result at what? Carbon dioxide. And after this reaction, what we will get? We will get the 97 kilocalorie of heat. So basically this reaction is a exothermic type of reaction. That's why what is happening after the combustion, we will derive some amount of heat. Similarly, when the carbon reacts with the half oxygen, that is the in presence of limited oxygen, what will happen? The carbon monoxide formation will take place, and here also this reaction is also what? Exothermic reaction, and as a result we will derive some amount of heat, and here the amount of heat is around 29.5 kilocalorie. So here we have already discussed the two zone, ash zone and the combustion zone. So our next zone is what? Our next zone is the reduction zone. In the reduction zone, what happens? This zone is known as what? This zone is their reduction zone because the reduction reaction takes place. So basically what we have told, our main reactant is coke, and there for the process, what we are doing, we are passing the air plus a little bit of steam. So in the combustion zone, air will react with the coke, and the following reaction, the conversion to carbon dioxide and carbon monoxide will take place. Whereas in the reduction zone, what will happen? Reduction reaction will take place. So here the carbon dioxide will again combine with the carbon to get reduced to carbon monoxide. And the second reaction is carbon is reacting with the water to form carbon monoxide and hydrogen. And in the third reaction, what we can see? We can see that carbon plus 2H2 that will liberate carbon dioxide plus hydrogen, and all these reaction we can see that these are endothermic in nature. What do we mean by the endothermic reaction? Endothermic means we have to supply energy from the outside to carry out such reaction. So what we have observed there in the combustion zone, the reactions are the exothermic. That means they are generating some extra energy and that's why the temperature that there was maintaining at around 1100 degrees centigrade. But here, as some heat will be consumed in the reduction zone for carrying out this reaction, so what will happen? The temperature will fall from 1100 to the 1000 degrees centigrade. So the third zone is known as the reduction zone. So mainly here what is happening here, the carbon dioxide is also again reduced by reacting with the carbon, and carbon is coke is reacting with the given steam to convert to the carbon monoxide and carbon dioxide, and all these reactions are endothermic in nature. Now the last zone is known as the distillation zone. Here what we have observed, the temperature of this zone is around 400 to 800 degrees centigrade. That means what? In this zone the temperature is much lower than the temperature of the combustion zone and the reduction zone. So what is happening here? The incoming coal is heated by the outgoing hot gases. In the reactor diagram, so if we go previously, so in the reactor what we have seen, the from the top we are feeding the coke, and from the bottom we are giving the we are passing the supply of air and a little bit of steam. So air and steam is going from the bottom direction towards the upward direction, whereas the coke is fed from the top of the reactor. So here in this zone what will happen, the incoming raw feed, that is the coal, will be heated by the producer gas, that means the outgoing hot gases, and as a result what happens, if some volatile matter remains present in the raw material, that is the coal, that will also vaporizes and mixes with the outgoing producer gases. So here in these reactions, in the production of producer gases, what we have seen, that the nitrogen present in the air remains totally unaffected during the reaction, and as a result we can see that a high fraction, 56% of nitrogen remains present in the ultimately in the producer gases. And from the after the reaction what happens, we can easily liberate or taking out the from carbon dioxide and nitrogen, carbon monoxide and hydrogen, that is the total mixture of these four gases which results in the producer gases. We can easily take out this gas from the side column of the from the side upper end of the reactor, that is the gas producer reactor. So now in the today's lecture, the last point is about the what are the major applications of the producer gases. So these producer gases are mainly used for the heating purposes. That can be in the open hearth furnaces, which are mainly used in the manufacture of steel and glass. And that can also be used in case of heating the muffle furnaces and different types of retorts, and it also acts as a very good reducing agents in case of the some metallurgical operations. So in the today's lecture what we have discussed the what are the some common synthetic gases, and among these first gases is one of the important is the producer gases. In terms of the calorific value, this producer gas is a very low, it delivers very low calorific value around 1300 kilocalorie per meter cube. Though it has the low calorific value, but it finds its wide applications in many areas. And also today's lecture we have discussed about the synthesis of the producer gas in a reactor named as the gas producer. And in the reactor what we have seen that mainly four zones are there. The bottom zone is the ash zone, followed by the combustion zone, then the reduction zone, and ultimately the distillation zone. So I think that today's lecture is clear to all.